Okay, let's try to do some examples with SN2 reactions. We'll try to knock out 5 examples in this one video. Okay, let's start with a simple one. What if we do something like ethyl bromide plus sodium azide? Primary halide, one of our slam dunk SN2 nucleophiles. This is definitely going to do an SN2. There's no stereochemistry, so we don't have to worry about inversion. And this will make ethyl azide. And if you want to be completist about it, typically I'm not, you can draw the salts. Sodium bromide is formed. Okay, that's one example. Now let's look at chlorobutane. This is a secondary halide, so it's a little bit hindered. So we're going to need one of our good nucleophiles, and we have that with sodium cyanide. Cyanide is going to attack. It attacks from the back face of this carbon-halogen bond. Therefore, we're going to get inversion of stereochemistry. Note I'm going to turn around my NC because the carbon is what's attacking, not the nitrogen. So we get inversion of stereochemistry. And that is another SN2. Let's look at another reaction. Bromide. And let's put something down here, OH. Here's a secondary halide. Again, for a secondary halide, we need one of our good nucleophiles. Are really good nucleophiles, not good but great nucleophiles. Here is sulfide. Sulfide, when it attacks, it's going to attack the back side of that carbon-bromine bond. That means in this case it'll come from the back face. That hydrogen which was back gets pushed to the front. The other stereocenter is untouched. So here we have the cis product. We end up with the trans product because we get inversion at the reaction but not at any of the other stereocenters. There's 3 examples. Let's see. Here we're doing a reaction that does not involve one of our great nucleophiles. This is with sodium methoxide, sodium methyl oxide. Typically when you use this, it's actually in methanol as a solvent. And you might say, oh, sodium methoxide is not as good a nucleophile. What saves this reaction is where you have a primary halide. This will still do an SN2 reaction. The halide gets kicked out. We replace it with methoxy. Again, if you want to, you can write out the salts. But the key product is here. There's no stereochemistry, so nothing to worry about there. Lastly, let's bring out another halide. In this case, we have a secondary halide, and we react this with sodium hydroxide. Note that sodium hydroxide is not one of our really good nucleophiles. Furthermore, we've paired it with a secondary halide, and this will not do an SN2 reaction. That kind of raises the question, well, what is it going to do? Here's one of our nucleophiles, one of these dark figures in the bar in the Western. It's going to do something. It's not going to stand passively by. The fact is, it is going to do something. It just won't do an SN2. The fact is, this hydroxide is basic, and in the presence of a hindered halide, it's going to do an E2 reaction. And so now is the time to transition from SN2 and to start talking about what is the E2 reaction.